Hello and welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the JAMB questions. And in this recording, we are looking at the UTME questions for chemistry for the year 2020. This is the first part of the recording where we are going to look at the first 20 questions. Before we continue, please don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at scholar.com to practice the JAMB exam and modular quizzes for free. Alright, first question here on atom, elements, and compounds. The electronic configuration of an element is given as this. How many unpaired electrons are there in the element? So we have this electronic configuration in the SPDF notation. The first thing we can do here is there are a whole lot of things that we can do here. Okay, we can determine which element this is by adding up these powers I have, these indices here. When we add up these indices, it will give us the atomic number of that element. So we have 2 plus 2 plus 6, okay, plus 2 plus 3, and that is 15. Okay, which element has the atomic number of 15? That is phosphorus. Okay, but basically we are not going to be using this. Let's now look at this diagram here, this diagram of orbitals, and look at how the elements are, how the electrons are paired rather. So in 1s2 we have this 2s2, 2p6. Okay, you can see all the electrons are paired. We don't have any unpaired electron here. 3s2 we have the 2 paired electron. But if you look at 3p here, okay, this p orbital can take 6 electron. Okay, 6 electron. It has 3, like 3 suborbitals here. Okay, where those electrons can be paired. But as you can see here, these 3 electrons here, they are unpaired. Okay, they are just single here, they are unpaired. So this element here that has been mentioned as this has 3 unpaired electrons. It has 3 unpaired electrons. Next question on mixtures. Which of the following can be obtained by fractional distillation? Okay, fractional distillation can be used to obtain liquid nitrogen rather, to obtain nitrogen from liquid air. Okay, from liquefied air we can obtain nitrogen from the fractional distillation of liquid air. Next, also on mixtures. Duralumin consists of aluminium, copper, and we have to identify the other constituent of duralumin. Duralumin is an alloy. Okay, and alloys are a combination of metals. Okay, the duralumin consists of aluminium, copper, magnesium, and manganese. Okay, magnesium, manganese, and a little bit of silicon. So the other constituent that we have here, okay, is manganese and magnesium. Next, an example of a polysaccharide is, so a polysaccharide is formed from the combination of monosaccharides. Okay, polysaccharides are masses of monosaccharides. And examples here, an example from what we have here is the starch. Okay, the starch is a polysaccharide. Other examples include cellulose and glycogen. Next, on acid, base, and salt. The best treatment for a student who accidentally poured concentrated tetraoxosulfate 6 acid on his skin in the laboratory is to wash his skin with water. Okay, adding cold water to an acid burn is a good first aid treatment. Next, we have a diagram here. Which of the gas laws does this graph illustrate? If you look at this graph here, this is a graph of volume against temperature, and as you can see here, this graph here slopes upward like this, and this indicates a direct proportionality. Okay, this indicates direct proportionality between the volume and temperature. What that means is that as the volume is increasing, the temperature is increasing. Okay, and if you recall the gas laws that we have, and all of these are from the gas law, the one that discusses the relationship between the volume and the temperature of a fixed mass of gas is the Charles law. Okay, the Charles law, which states that the volume of a fixed mass of gas is directly proportional to the absolute or the Kelvin temperature, provided that the pressure of that substance remains constant. Next, what are the possible oxidation number of an atom if its atomic number is 17? So the first thing we are going to be doing here is writing the electronic configuration of this, of this element using the KLML configuration, and that for this element is going to be 287. Okay, what that means is this element here has 7 electrons in its outermost shell. Now it can either donate those 7 electrons so that its outermost shell can now have 8 electrons. This once this is donated, and we don't have the shell again, then the shell that we're going to have here is going to be this will be like the outermost shell for that element, and that would have the octet, what we call the octet structure, that is, will have 8 electrons. So this element, in order to attain octet structure, can either donate these 7 electrons rather, or it can accept one more electron to make this 8. So that will make the oxidation number, the possible oxidation number, to be what? 1, like -1 if it accepts, like if it is accepting electron, or +7 if it is donating. So it will be -1 and +7. But there is a greater tendency that this element here is going to accept rather than donate, because it will take lesser energy to accept 1 electron than to donate 7 electrons. But the oxidation number is going to be -1 and +7. Next, on mixtures, what process would coal undergo to give coal gas, coal tar, ammoniacal liquor, and coke? That will be what is called the destructive distillation of coal. Okay, the destructive distillation of coal is the process by which any coal containing matter like wood, okay, is decomposed by heating in the absence of air. The products of this, the destructive distillation of coal, are coke, charcoal, ammoniacal liquor, coal gas, coal tar, and oils. Okay, so destructive distillation of coal would produce this: coal gas, coal tar, ammoniacal liquor, and coke. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry, and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next, on acid, base, and salt. Liquid black soap is made by boiling palm oil with liquid extract of ash. The function of the ash is to provide the ash provides the alkali. Okay, it functions as the alkali here. The soda ash acts as the alkali in the production of the soap. Next, on organic chemistry. When water drops are added to calcium carbide in a container and the gas produced is passed through a jet and lighted, the resulting flame is called an. So when drops of water are added to calcium carbide, okay, it will form calcium hydroxide and acetylene. Okay, the flame that will be produced, okay, if that gas is lighted, is going to be oxyacetylene flame. Oxyacetylene flame from the combustion of the acetylene in the presence of oxygen. So you're going to have oxyacetylene flame. Next, on mixtures, which of the following substances is a mixture? The seawater is a mixture of salts and water. Okay, a simple way to easily determine a mixture is to look at whether or not it has a chemical formula. If you look at the other options there, the granulated sugar has a chemical formula. The sodium chloride has a chemical formula. The iron filling is just iron. Okay, it's just iron, like elemental iron. But the seawater does not have a chemical formula. Okay, it does not have, it's like a chemical formula. Okay, it's just a mixture of water, salt, and some other dissolved particles like that. Next, on gas laws, if the quantity of oxygen occupying 2.76 liter container at a pressure of 0.825 atmol and 300 Kelvin is reduced by 1/2, what is the pressure exerted by the remaining gas? Alright, so if we use the general gas law, because this is a question, okay, involving volume in liter, pressure in atmol, and temperature. So you're going to be using the general gas law. Okay, where what you have on this side, your P1, V1, T1, they are the initial values of your pressure, your volume, and temperature, while these are the final values. So the initial values here for that oxygen, for that quantity of oxygen, is the pressure is 0.825 atmol, the volume is 2.76 liters, okay, while the temperature is 300 Kelvin. All right. Now, if the quantity of volume is now halved, okay, they said it's reduced by 1/2, it becomes half. That means that the new volume is going to be half of the original volume. The original volume was 2.76 liter. So half of that is half of this, is going to be 1.38 liter. We now want to look for P2. Okay, we want to look for P2. Now, we are assuming that the temperature is constant here. The temperature is kept constant, so the temperature did not change. Okay, it remained at 300 Kelvin. All right. So since we have a constant temperature here, we will rather use the Boyle's law. Okay, we use the Boyle's law. We just say P1 V1 is equal to P2 V2. Why? Because this T1 and T2, they will cancel themselves out. Since they are the same thing, they will cancel out. So you just have P1 V1 is equal to P2 V2. So this is what we are working with, and we are looking for P2, the new pressure, right? The new pressure. So what we do here to get P2 is to divide both sides by V2. We divide both sides by V2. So this side will become P1 V1 over V2 equal to P2 V2 over V2, and V2 will cancel V2 on this side. So you are going to just have P1 V1 over V2 is equal to P2. Okay, so remember our P1 and V1, the initial values that we have here is 0.825 times 2.76 divided by V2, that's a new volume, which is 1.38. So you are going to have P2 is equal to, by the time you multiply this and you divide that answer by 1.38, you get 1.650 atmol. Okay, so that's it. Now, another way we could have solved this question without even calculating, okay, without going through all of this, is if you have an understanding of the Boyle's law. The Boyle's law is states, or the implication of the Boyle's law is that the pressure and volume, they vary inversely. What does it mean when we say they vary inversely? It means that if the volume increases, the pressure would reduce. That is the meaning. Okay. Now let's say the volume doubles. If the volume should double, rather, the pressure is going to become what? Half. If the pressure doubles, if the volume doubles, meaning if it becomes multiplied by 2, then the pressure becomes divided by 2. It becomes half. That is the meaning. Okay. But if the volume becomes divided by 2, the pressure becomes multiplied by what? By 2. So you are going to have the opposite happening to them. Now in this question, they said that the volume, okay, was reduced by what? By 1/2. Okay, the quantity, which is the volume, is reduced by 1/2, meaning the volume was halved. If the volume is halved, then the pressure will be what? Will be doubled. The volume is halved means the volume is divided by 2, so the pressure will become multiplied by what? By 2. So we should have, what we could have done is just multiply this pressure by what? By 2. Since the volume was half, we know the pressure is what? Is double. Next on the periodic table, 4 elements P, Q, R, and S have atomic numbers of 4, 10, 12, and 14 respectively. Which of these elements is a noble gas? So the noble gases, they are those elements that are in the period 8, okay, in the group 8 rather of the periodic table. So what we need to do here is, how do we find, or how do we tell which of these elements is in group 8? Is we will write the electronic configuration, the KLML configuration of these elements using this atomic number. So for P with atomic number of 4, we are going to have 2, 2. For Q, it will be 2, 8. For R, that's 2, 8, 2. For S is 2, 8, 4. Now, if you add up these numbers, you see that it will give you back these things that you have here. Okay. Now, how do you determine, when you have your key element configuration like this, how do you determine the group of the elements? Is you look at the last number in the configuration. Okay. The last number in the configuration will tell you the group of that element. Now, what this means here is that this P here is in group what? Group 2. Okay. This is in group 8. This is in group 2. This is in group 4. Okay. And we have to identify which one is a noble gas. Okay. Noble gases, they are those in group what? Group 8. That is, they have 8 electrons in their outermost shell. And from this, we see that it is Q here that has 8 electrons in the outermost shell. So this belongs to group 8, which is the group of the noble gases. Another way that you can solve this question is to identify the names, okay, of these elements. To identify the names of these elements. So we look at, okay, which element has an atomic number of 4? That's beryllium. Beryllium is not a noble gas. Which one has of 10? That is fluorine. Okay, and fluorine is a, sorry, that is, no, not fluorine, that is neon, right? With 10, that is neon, and neon is a noble gas. So we could just tell by just, we can looking at which elements have these atomic numbers. Okay, if you read the periodic table, the 4th one is beryllium, the 10th is neon, and you have the other ones as well. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, it could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below. Next, on organic chemistry, the products of the thermal decomposition of ammonium triazonitrate are. When ammonium triazonitrate is decomposed under it, it produces nitrogen the nitrogen oxide and water. Okay, so we're going to have nitrogen 1 oxide or dinitrogen and water. Next, atom, elements and compound. How many valence electrons are contained in the elements? So in this representation here, when we have an element represented as this, okay, what you have here, this subscript here is the atomic number of the element, while the superscript here is the atomic mass of that element. So to get the configuration, what we use is the atomic number. Okay, but this is the atomic mass. We use the atomic number. So the atomic number is 15. If you write the configuration of this element, it will be 2, 8, 5. Okay, that's what is pictured there. Meaning that this element has 2 electrons in the K shell, then it has 8 in the L shell, then it has 5 in the M shell. Okay, the outermost electron or the valence electron are the elements in the outermost shell. Okay, and if you count here, we have 1, 2, 3, 4, 5. You can easily get it from the configuration by just looking at the last number here. Okay, that is the number of valence electrons that we have here. So we have 5 valence electrons in this compound. Next question, the number of molecules of carbon dioxide produced when 10 grams of calcium carbonate is treated with 0.2 dm cube of 1 mole of hydrochloric acid in the equation is, so we have the equation of reaction here. Alright, so from the equation of reaction that we have here, we see that 1 mole of this substance here, calcium carbonate, produced 1 mole of carbon dioxide. Okay, so it's 0.2 moles, as we have from the question, is 0.2 moles rather, is going to produce 0.2 moles of this as well. Okay, and same will also be with the volume. 0.2 dm cube of this will produce 0.2 of this. Okay, now what we want to do is calculate the molar mass of calcium carbonate. The molar mass is the mass of 1 mole of this calcium carbonate. Now in calcium carbonate we have calcium, okay, plus carbon plus 3 of oxygen. Okay, so what we do is we are going to add up the atomic masses of these elements in this compound here. So calcium is 40, okay, it is 40, carbon is 12, plus oxygen is 16, but we have 3 of it here, so this will be 3 times 16. So we have 40 plus 12 plus 3 times 16 is 48, and that will be 100 grams per mole. That means that 1 mole of calcium carbonate is 100 grams per mole. Okay, the next thing we are going to do is calculate the molar mass of the carbon dioxide. So in the carbon dioxide we have 1 of carbon plus 2 of oxygen. The atomic mass of carbon is 12, plus the atomic mass of oxygen is 16, and we have 2 of it here, so this will be 2 times 16. So here we have 12 plus 2 times 16 is 32. 12 plus 32 is 44. Now we said 1 mole of this of calcium carbonate produced 1 mole of carbon dioxide. That means that, and that 1 mole of calcium carbonate is 100 grams. Okay, 100 grams of this. Okay, 100 grams, and 1 mole of this is 44 grams. That's what we calculated. 1 mole of this is 100 grams. 1 mole of this is this. Alright, so if 100 grams of calcium carbonate produce 44 grams of carbon dioxide, then 10 grams of this will produce what of this? We want to calculate what mass of this carbon dioxide will be produced by 10 grams of this. So just represent that mass by x. Okay, now if you look at this now, from 100 to 10, what has happened is like saying we divide. Okay, we divide by 10. It's like dividing this by 10. So if we want to get what we are going to, what's supposed to be here, we just divide this 2 by what? By 10. That's a simpler way. Okay, that's a simpler way to do this. Okay, you can see that from 100 to 10 is divided by 10. So we divide this 2 by 10 to get the value of this x. So our x will be equal to 44 divided by 10, and that is 4.4 gram. Okay, so the next thing we are going to do now, so we know that this is the mass of the carbon, that is of the carbon dioxide that is produced, okay, with 10 grams of calcium carbonate. So what we'll do is calculate the number of moles of the carbon dioxide that is produced, and the number of mole, the formula is number of mole is equal to the given mass or the produced mass over the molar mass. The given mass or the produced mass of carbon dioxide here is this 4.4 gram. That is the mass of the carbon dioxide that was produced here, 4.4 divided by the molar mass of carbon dioxide, which is what we calculated here as 45. So you have 4.4 divided by 45, and that is equal to 0.1. Okay, is 0.1. So this is the number of moles of carbon dioxide that is produced from this reaction here. Now 1 mole of carbon dioxide contains 6.02 times 10 raised to the power 23 particles. Okay, that is for 1 mole. For 0.1 mole, okay, which is the number of mole that is produced here, that is 0.1 mole is going to be 0.1 times this value here, 0.1 times 6.02 times 10 raised to the power 23. 0.1 times 6.02 will give you 0.602. Okay, now what I'm going to do is I'm going to borrow 110 from here. This is 10 raised to the power 23. I'll borrow 110. If I borrow 110 from here, this becomes 10 raised to the power 22. What do I do to that 10 that I borrowed? I'll use it to multiply this thing here. Okay, so I'm going to have 0.602 multiplied by a 10 that I borrowed from here. So this will be 6.02 times 10 raised to the power 22. Next question: the volume occupied by 1.58 gram of a gas at STP is 500 cm cube. What is the relative molecular mass of the gas? Alright, the relative molecular mass of the gas is going to be the weight of 1 mole of the gas. Now the volume of 1 mole of the gas is 22.4 gm cube at SCP. If we convert this to cm cube by multiplying this, that will be by multiplying this by 1000, we are going to have 22,400 cm cube. Okay, now from the question, 500 cm cube of this gas weighs 1.58 gram. So we want to know what will be the weight of 22,400 cm cube. So how do we do that? We simply divide this volume by that 500 and multiply it by this weight here. Okay, so you have 22,400 divided by 500 times 1.75. okay, and when you multiply the value from here by 1.58 rather, you'll be getting 74 grams. So that means that 22,400 cm cube, okay, will produce 74 grams of this, okay, and that will be the molecular mass of the gas in question. Next question: which of the following gases will rekindle a brightly glowing splint? That is the nitrogen oxide, okay, or nitrogen 1 oxide. It will rekindle a glowing split, a brightly glowing split. Alright, the last question in this recording: the shape of ammonia molecule is triagonal planar. That's the shape, okay, it is triagonal planar. Okay, don't forget to check out our playlists. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at scholarfedu. Okay, like and share our content, and visit our website at scholar.com to practice UTME exam and modular quizzes for free. Thank you.